I'd like to explore one last way that redundancy can appear in a database. And now this one is where there can be some debate about between purity of normalization versus efficiency and performance. So I've got a little example database here for a blog where we have users that make posts and comments about those posts. And so we've got all the relationships in here. A post is created by a user. A comment is also created by a user, and it's created about a particular post. So that is what our database looks like. And then for record keeping purposes, we also keep track of how many comments a post has. We keep track of how many posts a user has, and then the total number of comments that all of those posts have. And so that's our database, and there is no number, there's no text, there is no relationship here that you're going to see repeated like we've seen previously. The difference is, however, these number of comments, number of posts are redundant because that information is already stored in the database, and there is actually SQL queries to compute the number of comments for a post and the number of posts for a user, and then you can roll that up and get the number of comments for each post. So these right here, these number of posts, number of comments, are redundant in that sense. We already know how many comments there are for that post. We know how many posts a user has. And so we don't want to have, in a theoretically pure sense, values that we can already compute with the data that we have. Because then if we add a new comment but we accidentally fail to update this number of comment, we can have an inconsistency where we've added a comment but we haven't reflected that in here or in here, and that can be really easy to miss. That's our update anomaly, and we don't want to have room for that to take place. And so this is a really simple example, but these happen all the time. Let's say you have an order. So you have users with orders, and each order has line items that cost a certain amount. The total for that order is a sum of each line item. Are you going to put the total in the order, or are you going to keep the cost for each line item separate? Now, assuming that your product prices don't change, that's an unnecessary point to do. Now, that is an example that you might see more frequently in a database than this more sterile example I've gone here. But the idea still remains. If you can compute the value, you don't want to put it in the database. Now, some people might rightly argue that, well, true, you can compute that from the database, but if you're going to do that frequently, that's going to be a high-cost operation if you've got a large enough database and you're doing that for a large number of orders or posts or users or whatever the computation is. It might be easier when you are entering the data into the database to do that computation, and doing the retrieval is going to be faster, less costly than doing the computation on that data. And so that might be true. And so that's an example that you might run into where you say, well, in an ideal world, we want to have a normalized database, and we don't want to have this redundancy. But because for performance reasons, we can't afford to do that, we're going to de-normalize our database, and result is going to be a faster database that results in getting stuff out of the database at the speed we want to. However, I want you to make sure that you don't ever design your database with performance assumptions. So design it normalized run it normalized, and then when you measure a performance problem, that's when you go back and denormalize the database, because you don't want to have to deal with these redundancies unnecessarily. You want to intentionally put them in there because you have found that there is a performance problem and it doesn't make sense for your database any longer. But until then, you want the easiest to update, the easiest to insert, delete, manipulate as you can, because ease of use trumps guess at whether or not you are going to have a performance problem. And the reality is, we as humans tend to be very poor at guessing where the performance problems are going to be in our applications. If we think it's going to be over here, it oftentimes ends up over there. And so it's better to design it in a kind of a purist form and run it through your architecture and your system and discover where the performance problems are, rather than guess where the performance problems are, optimize it incorrectly, and you have to go through a second round of optimizations and deal with your problematic inserts and updates and deletes that you wouldn't have had to do if you had done it the way you wanted to the first time. So it's really important to start with a normalized database, remove these redundancies, don't allow plural multi-valued fields to slip in, and then you can go back later and put those in with a denormalization step for performance purposes and only for measured performance purposes.